Welcome to CEC lectures. Myself Dr. Preeti Jagwani. I am from Department of Computer Science, Arabic College, University of Delhi. So in our series of this database management system, presently we are going through the topic of normalization, and how we have kind of arrived at this topic is, so let us take a quick recap, and then we will further start with this normalization in detail. So you remember we were talking about the data modeling thing, and in data modeling we can say that we were actually going through the two major terms. One was the ER diagram and another one was the normalization. ER diagram we have seen in much detail along with extended ER diagrams also, and we have also started with normalization. So these are the two basic terms which are required for when we talk about the data modeling as a process. So normalization we were talking about. Let us take a quick recap of what actually the normalization is. So normalization is basically a technique that is going to reduce the data redundancy. Also it will eliminate the characteristics which are undesirable, like anomalies. Anomalies as mean we'll be taking clear and detailed examples of anomalies, but for as of now we can say mistakes, we can say. So insertion anomalies, updation anomalies and deletion anomalies, that will also be eliminated with the help of normalization. And as far as the process is concerned, this normalization actually is going to divide the larger tables into some smaller and link them using the relationship. So this is what if we talk about normalization in a nutshell, that the process of normalization, that what it is going to do. So actually in the process of normalization we are going to split the larger tables into the smaller tables and link them using the relationships, and the agenda here is we want to reduce the data redundancy. Also we want to eliminate the insertion, updation and deletion anomalies, and the purpose is to ensure we want to ensure that the data is stored very logically and the data is also we can say consistent. Inconsistent with each other. So this is what we call normalization, and the objective here is to present a set of rules that tables and databases must follow to be well structured. We want our database to be well structured, and for that we have a set of rules. That set of rules comes under we can say the purview of, or comes under the umbrella of normalization. And basically this normalization is presented as a sequence of normal forms, or we can say levels of normalization we also call it. So these levels of normalization are based on the amount of redundancy in the database. So what are these various levels of normalization are? These are first normal form, second normal form, then we have third normal form. Apart from that, we also have Boycott's normal form, which is more specifically known as BCNF. Then we have fourth normal form, which is 4NF, fifth normal form 5NF, and after that we have domain key normal form, which is in short known as DKNF. And in order to kind of avoid the database anomalies, now the question which comes up, that do we actually need to ensure all these levels of normalization, or do we actually need to ensure the compliance of our databases and tables with all these levels of normalization? So presently we have seen 7, starting from first to fifth, and addition of Boycott's normal form and domain key normal form are there. So total 7 normal forms are there. So the answer here is that most databases should be in either third normal form or BCNF, which is Boycott's normal form, in order to avoid the database anomalies. So if the agenda is to avoid the anomalies in the database, whether it's the insertion anomaly, update anomaly or deletion anomaly, we can say that 3NF third normal form or Boycott's normal form is actually, we can say, sufficient. Now what are the basic characteristics, we can say, of normalization? So in normalization, as I have already told you, that we are going to split the larger tables into the smaller ones. That means it is very sure that number of tables is going to increase, at least it is not going to decrease. And apart from that, The complexity in kind of maintaining the database is also going to be increased, but yes, the redundancy, which is kind of, we can say, a very important characteristics, and that should be kind of reduced. We can say the redundancy is going to be reduced if we are going with normalization. So in order to go with, or when we go with normalization, redundancy will be reduced, number of tables because of the kind of splitting of large tables is going to be increased, and complexity, yes, we can say we are actually increasing the complexity. And if you can see levels of normalization or different forms of normalization, if we talk about, so each higher level we can say is subset of the lower level. So for example, we have first normal form, and then when we are ensuring the second normal form, that means the first the database or the table which is in the second normal form, that means already the existence of the first normal form is ensured, then only it is going to go into the second normal form. Or moving forward, if we talk about that database or a table is in third normal form, that means it is already complied with first normal form and second normal form both, then only it is going to get into the third normal form. Similarly, if we talk about fourth, that means the compliance with 1NF, 2NF and 3NF should be there. And finally, if we talk about domain key normal form, which is DKNF, then it should comply the when a database is entering or when a table is entering domain key normal form, that means one thing is assured, that it is already in first normal form, it is already in second normal form, it is already in third, fourth and fifth normal form as well. So each higher level we can say is a subset of the lower level. So this is what we can say is the correlation between the levels of normalization. So till this point we have understood in detail that what actually is normalization, what are different levels of normalization, we have seen the names, or we can say what are different forms of normalization. And now let us try to explore the forms or levels of normalization one by one. So the first level is actually the first normal form. Now the first normal form says that a table will be in the first normal form, or a table is in the first normal form if and only if, IFF as in if and only if and only if the domain of each attribute contain only atomic values, and the value of each attribute contains only a single value from that domain. So domain, which is actually the pool of values from which the different values corresponding to a field in an attribute field or an attribute are kind of, we can say, taken or are selected, that pool must contain atomic values. And apart from that atomic values, when these values are coming into the attribute of a database or attribute of a table specifically, then each attribute must contain only a single value. Or we can say in layman terms, we can talk about it like this, that every column of the table should only contain single values. There will be kind of no multiple values, no composite values, and so on and so forth. So let us try to understand this with the help of an example. So here we have taken a very small a snapshot of a table from a library in which there are only two columns, and for the sake of simplicity, to make it simple, we have only taken two rows. So one is patron ID, another one is the borrowed books. So patron ID is the ID of the ID of an individual, and what all books he or she has borrowed, that are kind of written in the next column. So here if you can see, your patron ID, which is C45, has taken three books. One is B33, another one is B44, and third one is B55, while C12 has taken B56 only. So where is the problem? So can we say that this particular table is as per the rules or as per the constraints of the first normal form? No, we cannot say that, because this particular table or this particular screenshot of the table is not actually we can say following the rules of the first normal form, or it is not complied with the first normal form. Now why? Because here if you can see that C45 is having 3 values. So that means this is not having a single value. The attribute borrowed books is having single value for C12, but for C45, but for patron ID C45 it is not having single value, instead it is having 3 values. So we will see that how this can be kind of checked, how this can be removed, or how we are going to convert this particular database into something which is complied with first normal form. And we are also going to see that what are the actually constraints when we are going to keep it like this. That means what if we don't ensure the first normal form, then what is the harm in doing that? That we will also try to understand. So let's see. So first, and if solution of this particular kind of a screenshot or this particular instance says you need to repeat patron ID thrice, which is C45, C45 and C45, and then C12, and the books borrowed are B33, B44 and B55, and then B56 for C12. But yes, so what is happening here is that's what I was telling you, that complexity is going to increase, but redundancy we talked about that it is going to decrease. That we will see how it is decreasing in upcoming levels, but presently it feels like this may not be kind of true. So here C45 is having a book borrowed B33, also it is having B44, and also it is having B55. Sorry for the mistake, which is B33 is repeated twice, please take it as B55. Then C12 is having B56. So this is actually the solution of the previous table, which was not in the first normal form. That means the values which are stored or inside an attribute are actually not single valued, not single values we can say. But here if you can see, so yes, it is every patron ID is having one single book borrowed, although we are repeating C45 thrice, but only one book borrowed, identity of one borrowed book is written in the column. Any column is not having multiple values, both the columns are having single values. So this we can say, yes, it is kind of ensuring that the first normal form is being complied with as far as this database or this instance is concerned. Let us take another example, which is there may be foreign airlines. So what is the flight number and what are the weekdays on which it is operating? So let's see. So we have UA 59, which is going on Monday, Wednesday and Friday. Then we also have UA 73, which is running all the weekdays, which is Monday, Tuesday, Wednesday, Thursday and Friday. So please observe again the as like in the previous example, the attribute which is weekdays is actually having multiple values. So based on the similar lines, what are we going to do? We are going to repeat the flight number UA 59 thrice, and in the attribute which contains weekdays, we are going to write the attributes individuals as it is shown in the as it is shown on the screen. So one and if solution is, we will write flight number UA 59 on Monday, then flight number UA 59 on Wednesday, then flight number UA 59 on Friday, then flight number UA 73 on Monday, UA 73 on Wednesday, Tuesday, Thursday, Friday, and so on and so forth. So this is what is one idea in which we are going to make a database complied with the we can say first normal form or the constraints of the first normal form. Now when we talk about the term database modeling, we have started from here that we have seen two terms. One is ER model, which is actually kind of modeling the database onto we can say in various forms. Sorry. Now the point is, if we are going to watch out for the constraints of first normal form while looking into the modeling of the database, what is going to be the implication for the ER model? How this ER model is going to be designed, or what are the watch areas we need to see while modeling or while designing my ER model. So, while designing my ER model, if I want to be careful about the first normal form, we need to watch out for the entities that can have multiple values for the same attributes, for example phone number. So, nowadays it is a very common scenario that many individuals or many persons are having multiple phone numbers. So, is it a good idea to store uh, phone numbers or multiple phone numbers in a particular attribute, or what is to be done? Because if we are going to store multiple phone numbers in a single attribute, then in that situation it will violate first normal form, as we have seen in the previous examples. So, the first implication for the ER model is going to be, we need to watch out for the entities that can have multiple values for the same attribute. And please recall that when we were talking about the first normal form conditions, we have seen we have kind of taken a look at one condition, that all the domains should have atomic values. So, when we talk about a university database, or when we are talking about, let's say, a course schedule, and it is running from Monday to Wednesday 5:30 to 7 p.m. So, can we call it this 5:30 to 7 p.m. on Monday and Wednesday as a atomic value? That we need to kind of take a design decision over there. Here we can do Monday 5:30 to 7 p.m. and then in the next row we can have Wednesday 5:30 to 7 p.m. So, we can treat them as the atomic time slots. This could be one of the solutions. Now, the problem is, why do we need to have anything or any database into first normal form? Why this first normal form is necessary? What are the problems which are going to arise if we are not going to comply, or our databases or our tables are not complying with your we can say first normal form? So, in order to understand that, let us see the figure which is available on the screen. Here I am having a table which is having two we can say attributes. One is item name, another one is foo. So, foo here is any random value we can say. So, whereas item name is A, the value of foo is 25, the item name is B, the foo is having multiple values which are 25 and 35. When we talk about C, the item name C, it is having two values, one is 10, another one is 40. D is having only one value, while E on the other hand is having no value. Now, what is the problem, which is now clearly you can see here that this is a table or this is a database which is obviously non-compliant with the first normal form. So, what is the problem? So, the problem here is, when we are going to, let us say, fire a particular, or when we are going to shoot a particular SQL query, and we want to compare the value of this foo thing, which is I have told you it is a random number. So, all comparisons within a single predicate must be done against a single attribute that is there. So, for example, if we want to compare foo with a value, so it can be compared, or it can be, this comparison can be done against a single attribute. Now, let us consider a query. The query says foo greater than 20 and foo less than 30. will return A and B both, because A greater than 20 is 25 and A greater than 20 is 25 is also present in B, while A less than 30, 25 is kind of we can say satisfying that condition, while 35 is not satisfying. But yes, one of the component of B is also satisfying both the conditions. So, A and B, the answer will be both A and B. Now, the question is, are we actually satisfied with this type of answer? Now, here that is what I was trying to say, that all of the comparisons within a single predicate must be done against a single attribute. So, foo greater than 20 and foo less than 30 will return both the items A and B because of the presence of value 25 in A as well as in B. Now, let us say let us see another query. So, if we are going to pick another query, let us say foo greater than 20 intersection foo less than 30. So, this is going to return A, B and C both, because C is also having a value 40, if you can see, which is satisfying the condition. So, we have C here, we have A and we have B here. So, it will return A, B and C when we talk about foo greater than 20 intersection foo less than 30. This is because the first predicate will match 40 in C and the second one will match 10, which is also present in C, and hence therefore C is added. So, what is actually happening here? Multiple comparisons corresponding to a single attributes are being done. Or since these conditions are expressed on the different predicates, although they refer to the same attributes, they are not evaluated over the same value. They are evaluated over multiple values because of the presence of those multiple values here. So, that is what the problem actually is, that this presence of this multiple values is giving us a problem. Now, for example, we are going to trigger one more query, which is we are looking for foo greater than 20 and foo greater than 30. This should be same as foo greater than 20 intersection foo less than 30, ideally it should be. But here in this case it is not going to be same because of the kind of we can say introduction of the term introduction of the row C in our result set and presence of these multiple values. So, these predicates are evaluated on different values. So, one condition of the predicate is being evaluated on the value 10, another one is being evaluated on the value 40, and as both are being satisfied, it is entered into the answer. But the point is both of them are not satisfied with one. That means both the conditions are not satisfied with 10, only one condition is satisfied. Similar for the 40 also, it is also not satisfying both the conditions, it is satisfying only one condition. So, that is what the problem is, presence of we can say multiple attributes, multiple values in an attribute is also going to be is actually a problem. Now, is it actually a problem only in we can say when we are querying the database? So, the answer is no. Manipulating the data is also becoming very difficult, because whenever you are going to update an item, one must be specified that whether the new value should be added to the existing one, or they are going to be the existing values are going to be replaced. We actually that has to be specified. But if only one value is present, then it is not going, or only one value can be there or one value should be there, this question will not be arise. That means the new value is obviously going to override the previous one. But if the previous one is having multiple values, so this can override one of the values, this can override all the values, or this may get added into the list. So, also we can see that one thing here is, working with denormalized form may seems very appealing due to the modeling process, due to its flexibility introduced in the modeling process, as we have seen that it's a very kind of we can say fascinating or lucrative idea to write airlines number in one particular attribute and corresponding days using comma multiple values, because it is giving us the flexibility. But it also requires being extra careful when we are querying and manipulating the data, and we have seen the example. Also, one thing which I told you that I will be addressing in the upcoming slides was about the redundancy. When we are repeating that C49 multiple times, redundancy is actually, we can say, introduced. So please remember that first normal form does not eliminate the redundancy in the data, though the higher normal forms eliminate the different forms of redundancy, but this is not case with the first normal form. But yes, first normal form is going to kind of, we can say, help us in eliminating the other anomalies, as I have told you that update is going to be a problem, or insert can also be a problem. So it will help in elimination of those anomalies, although it is not going to help in elimination of redundancy as far as only first normal form is considered. So in this lecture we have seen, we have started with the recap of normalization. We have drilled down into the definition, objectives and forms, and also we have seen one which is the first normal form in detail along with the examples. We have also seen that what is going to be the repercussion if a database or table is not there in the, or is not complied with first normal form. Here is a list of references from which we have taken the examples and all that. These references are being used for the preparation of lecture. Hope you have enjoyed. I will see you in the next one. Till then, take care. Goodbye.